I really do think this might be one of my favorite things to talk about. So in the last section, we saw how things get phagocytosed or yumptialized into the cell. And the reason why I want to talk about the MHC platform right now is because that nonspecific phagocytosis, there's a process that can happen where we can post information about what was phagocytosed, and then the rest of the body can benefit from the information about what was inside you. So I want to talk about how the complex is actually formed. So I brought back this picture that we just drew because this was my nonspecific phagocyte, and you have this visual of how we could actually end up with my pathogen inside a vesicle inside this cell. And that process, the next step is actually going to be to take this pathogen and break it up into pieces. So ultimately, inside this little vesicle, we will have little parts. So we'll break this guy up, and we'll end up with parts of the guy. As soon as we have broken it up into parts, this vesicle is going to fuse with the endoplasmic reticulum. And pathogen parts are going to dump into the endoplasmic reticulum. Now, if you think about what the endoplasmic reticulum does, it's involved in processing proteins. Inside the endoplasmic reticulum are empty MHC platforms. Okay, so here we are. We have endoplasmic reticulum, and we have an empty MHC platform, which surely must be this color. So this is kind of how I'm drawing my MHC platforms. The endoplasmic reticulum just got pathogen parts, and it does it where there's this whole chemical, like, magic. Oh, it's so amazing, whereby pathogen parts get posted onto this MHC platform. Actually, anything can get posted on there. Anything, any, like, self molecules, like just metabolism results. I'm making this hormone, and little pieces of that hormone are going to get posted on this MHC molecule. So it doesn't have to be a pathogen that goes on it. The endoplasmic reticulum is constantly producing these MHC, these loaded MHC platforms. If you just ate a pathogen, then you're going to load it up with pathogen parts. From the endoplasmic reticulum, I know y'all remember this. Endoplasmic reticulum, like, bubbles off and forms these little vesicles that then travel to the Golgi bodies, where the vesicle is, like, packaged, and what you're packaging is an MHC platform in a vesicle that then is exocytosed into the cell membrane. And it isn't, I mean, look at how I've drawn the MHC platform in this vesicle. I drew it so that you can see that it's actually embedded in the vesicle, so that when you exocytose that thing, when you combine the cell membrane and exocytose it, you're going to have an MHC platform that is now embedded in your cell membrane. And it's not an empty one. It has evidence of what you did. You just posted your dinner. You just posted the fact that you were invaded. So now you have, or you posted that, you know, we went to the fair with our kids. I had cotton candy while I was there. It was awesome. I'm not getting enough sleep. Whatever. All of that gets posted on the MHC platform. Now, there's two flavors of MHC. There's MHC1. Every single nucleated cell in your body has MHC1 platforms. They're coded for by genes They're very specific to you, and they're one of the biggest reasons that I can't, like, rip off my arm and give it to you, and you rip off your arm and give it to me, and we can, like, trade. No. Why can't we trade? Because my body's going to straight up stone cold reject your arm if I try to sew it on there, and your body's going to do the same to mine unless we're, like, super related to each other, or we've gone through all this testing and we find that, you know, we have a lot of similarities in our MHC platforms, because all nucleated cells have these, which means who doesn't have them? Who doesn't have a nucleus? Red blood cells. Red blood cells do not have MHC1, which means what about blood transplants? Dude, you can totally do it because your red blood cells don't have MHC1. If they did, blood transfusions, donating blood, like, we wouldn't do it. You'd wait until you had a match, and then you'd, like, donate blood to the person with the match. Like, thank goodness our red blood cells do not have MHC1, because otherwise we'd never be able to donate blood to anybody. Or it would be very rare. It would be like the difficulty, you know, you get on the donor list and you have to wait for forever, not because there aren't organs available, but because it's really hard to find a match. When there is an organ available, it probably isn't one that's going to match you. Also, when you get some sort of an organ transplant, you have to go on anti-immune system drugs to tell your own immune system to chill its jets, because you're putting in something that isn't you. So most healthy immune systems will attack that thing that isn't you, because they will recognize that, yeah, that MHC1 doesn't belong to me. Okay. Dude, this is so awesome. So MHC1 and 2 are super important in the acquired immune response. But our next innate immune player is going to respond to something about MHC1. So let's talk about the natural killers.